Assalamu alaikum, dear students. How are you? I think all of you are well in this situation. I am also fine. I am Hiron, Associate Professor and Head of the Department, Statistics Department, Eden Mohila College, Dhaka. Welcome to all of you on behalf of Eden Mohila College online class. Our today's topic is mean tests, which is second year non-major course statNM 202 Principles of Statistics. Earlier I have discussed several mean tests. Mean tests are four types. That is single mean test or specified mean test, two mean test. Today I shall discuss test of equality of two means for paired observations, test of several means. Test of equality of two means for paired observations. That is, when the observations are paired, then how we can test of equality of two means. That is assumptions. In this case, assumptions. A random sample of size n pairs of observations is drawn from bivariate normal distribution. A random sample of size n pairs of observations drawn from bivariate normal distribution. Hypothesis: mu1 equal to mu2, that is we can write mu1 equal to mu2 0, that is mu d equal to 0, alternative mu d equal to not 0, where d means difference. D means difference of paired observations. Test statistic. Test statistic. The appropriate test statistic is t test d bar is d divided by root over n, which follows t distribution with n minus 1 degrees of freedom, where di equal to xi minus yi, d bar summation di by n, this is square we know, summation d square summation d whole square by n. And finally comment. We know if calculated d is greater than tabulated d at 5% level of significance, then we may reject null hypothesis, otherwise accepted. So to test equality of two means for paired observations, at first we can write assumptions. Assumption is a random sample of size n is drawn from n pairs of observation from bivariate normal distribution. And next, hypothesis, mu1 equal to mu2, that is mu d equal to 0, there is no difference, and mu d not equal to 0. Test statistic, the appropriate test statistic is t test, which is enumerated, and the finally comment. Here we know if calculated D is greater than tabulated D at 5% level of significance, then we may reject null hypothesis, otherwise accept it. Test of equality of several means last of mean test of equality of several means. At first assumptions, since it is several means, so we can let k random sample are selected from k normal population. Several means, that is k observations, we can select k observations. K means 4, 5, 6, 7, etc. K random samples are drawn from k normal populations. Next, these samples are independent. These samples are independent. This is assumption. Next, hypothesis. Null hypothesis mu1, mu2 up to mu k alternative, at least one of the equality does not hold. At least one of the equality does not hold. This means that all the groups are equal and at least one of the equality does not hold. Next, test statistic. Test statistic. The appropriate test statistic is F test. Here the test statistic is F test, which is between sum of square by k minus 1 within sum of square by n minus k, which follows F distribution with k minus 1 n minus k. Here we have to find total sum of square, that is x0 square gt square by n. Next, between ss ti square by ni minus gt square by n within ss equal to total ss minus between ss. And finally comment. If calculated f is greater than tabulated f at 5% level of significance, so we may reject null hypothesis, otherwise accept it. So viewers, this is our mean tests. Now variance test. Variance tests. test for a specified value of a variance. This is single variance. Test for a specified value of a variance. At first we know assumption. A random sample of size n is drawn from normal distribution. Population mean mu is unknown. A random sample of size n is drawn from normal distribution. Number 2, population variances are population mean are unknown. Hypothesis sigma square equal to sigma 0 square. This is a specific value. Alternative sigma square not equal to sigma 0 square. Next, test statistic. Test statistic. This is chi-square test. The appropriate test is chi-square test n minus 1 s square by sigma 0 square, which follows chi-square with n minus 1 degrees of freedom. Comment. Finally, comment. H0 is rejected if calculated t is greater than tabulated t, otherwise accepted at 5% level of significance. Test for a specified value. Equality of two variance test. Number 2, test of equality of two variances. A first assumptions. Two random samples are drawn from two normal populations. Two random samples are drawn from two normal populations. Two samples are independent. Population means mu1 and mu2 are unknown. This is our assumptions. Test of equality of two variance. At first, assumptions. Number 1 assumption. Two random samples are drawn from two normal populations. Two samples are independent, mu1 and mu2 are unknown. Assumption, hypothesis. Hypothesis is null hypothesis. mu1 square mu2 square, alternative mu1 square not equal to mu2 square. And next test statistic. The appropriate test statistic is f equal to s1 square s2 square, which is large s1 square or s2 square, which is small. So it is we have to estimate s1 square and s2 square from the data, and which is large, this is numerator, which is small, this is denominator. If we let s2 square s1 square is greater than s2 square, then this is which follows self distribution with n1 minus 1 or n2 minus 1. If we let s2 square s1 square, then n2 minus 1, or this is n1 minus 1. Where s1 square equal to, we know, n1 minus 1 summation x1 square summation x1 whole square by n1, s2 square equal to n2 minus 1 x2 square x2 whole square by n. Comment. As usual, if calculated t is greater, calculated f is greater than tabulated at alpha percent, level of significance and selected degrees of freedom, then we may reject null hypothesis, otherwise accepted. Test of equality of several variances. Test of equality of several variances. Number 3. At first assumptions, k random samples are selected from k normal populations. These samples are independent. Assumptions, k random samples are selected from k normal populations. The samples are independent. Next, hypothesis. Is 0, sigma 1 square, sigma 2 square, sigma square, at least one of the equality does not hold. This is hypothesis. Next, test statistic. Test statistic. The appropriate test statistic is chi-square test, which is mu log s square summation mu I log s square 1 plus 1 by 3 k minus 1 summation 1 summation. This is chi-square distribution with k minus 1 degrees of freedom, where mu I equal to ni minus 1, that is degrees of freedom, nu equal to summation mu I, s square equal to summation mu I s square by nu. And finally, comment. If you rejected, you calculated chi-square is greater or tabulated chi-square at 5% level of significance and k minus 1 degrees of freedom, otherwise accepted at 5% level of significance. So viewers, today I have discussed mean test, two mean test for paired observations, several mean tests, variance test. In variance test for a specified value of a variance, that is single variance test, two variance test and several variance tests. No more today, viewers. See you another day, inshallah. Allah Hafiz.